Okay, so now we're going to go ahead and jump into graphing our very own rational equation. We are not going to punch any numbers in on a calculator. So remember again for this lesson, everything is in factored form. So I'm going to jump right to number 2, which are wholes. There will be holes in some of your graphs, and remember a hole is a point of discontinuity. It's a break in a graph. It can be a vertical asymptote, or it can be an actual hole. And an actual hole is where it skips an ordered pair. And we'll talk more about that in our next example. I know I do not have a hole here in this graph because none of these binomials cancel out each other. Almost, but not quite. If this binomial right here, x plus 1, would have been the same expression as this, they would have canceled out. But they're not the same. They have different signs in the middle, so there are not going to be any holes in our example. Our first example is not going to have any holes. But that's not true for vertical asymptotes. So when you go to look at the vertical asymptotes, the only thing that you are focused on is the denominator. So I don't care about anything that goes on in the numerator. I don't care about those binomials. The only thing I'm concerned about are the binomials or the factors in the denominator. If you look at the first star right here, these binomials have degrees, just like what you learned when you did your polynomial unit. The degrees determine the end behavior of the graphs. So again, those words end behavior, keep in mind that I mentioned the words same and the words opposite. Those two words are going to come into play right here. For the second star, if the exponent or the degree is odd, then the end behavior is going to be opposite. If the exponent or the degree is even, the end behavior is going to be the same. I always remembered which was odd and which was even, and which behavior it determined, because the word, to me, odd, started out the same as opposite. So odd and opposite, those kind of sound the same, so I was always able to remember the opposite behavior went with an odd exponent. Okay, so now we're going to actually determine the vertical asymptotes, those brick walls that the graphs are not going to jump. So we're going to take each of these equations, set them equal to, each of these expressions, set them equal to 0 and solve for x. So we are going to have our first equation, which is going to be 2x plus 7 equals 0. Of course, when you solve for x, you're going to get negative 7 halves. And remember, we're graphing here. I cannot really graph a 7 halves, so go ahead and turn it into a mixed number, or you can put it as a decimal, whatever helps you visualize when you do your sketch. So we're going to have x equals a negative 3.5. And then for our other polynomial, that's a positive 1, but we're not done yet. Now that we've set them equal to 0 and solve, we need to go back and label this part. So for this polynomial right here, this is what I'm going to be focusing on. That expression has a degree of 1. It's understood to have a degree of 1 right there. 1 is odd. So this vertical asymptote right here is going to have opposite behavior. And I'm going to go ahead and write that in my notes. That way when I go to graph this stuff, I don't have to go back and check. So I always write a little reminder right here that that's going to have opposite behavior. Let me fix that. There we go. And of course, for the second polynomial, remember that had a degree of 2. 2 is even. So I'm going to write the word same next to this one. Now, don't get discouraged yet. Remember, when you go to graph rational equations for the first time, we're going to go through all of these pieces of the puzzle, and then we're going to put the entire puzzle together when we go and do graphing on an x and y axis. On to the next step, which is going to be horizontal asymptote.